Hi, this is Mrs. Vrobel. This is Chapter 3, Matter, Its Property, and Changes, and this is Part 3 out of the series. As you see here, we have a few objectives that we're working on with this video. So first, we're going to be looking at the difference between elements and compounds. Next, we're going to explain how do compounds obey two laws. One is definite proportions and the other is multiple proportions. And then lastly, we're going to look at the organization of the periodic table. Okay, so elements. What are elements? You've probably heard this before, but it's good review. It's the simplest form of matter. So it's like the building blocks of life or our environment. Elements cannot be broken down into simpler substances by chemical means. Now, what does that mean? We know that there's subatomic particles. We're not using that information to describe the element right now, but it's important to remember that elements are the basic level of chemical reactions. So we're not talking about combining atoms or electrons to get a chemical reaction. We're talking about combining atoms to get a chemical reaction. Okay, so for instance, water. The question is, what type of material is it? An element or is it a compound? Now, please remember, water is H2O. So if it's H2O, it must be what? A compound. Okay, oxygen. Oxygen. Now, you have to be careful because oxygen is O2. Question is that an element or a compound? It's actually an element because there's only one type of element in that substance, okay? All right, sucrose. Sucrose is sugar. I'm not going to write down the formula for that, but would you say that's an element or a compound? Yes, it's a compound. Okay, and then the next one is glass. So if you had to guess, do you think glass is an element or a compound? Correct, it's a compound. Okay, you can practice with these other ones and then tell me whether or not they're elements or compounds. We'll check them in class. Okay, now the interesting thing is, it took a long while for them to figure out what's the difference between an element and a compound. Empedocles, I don't know if I'm saying that correctly, he was one of the Greeks that came up with the idea that all matter has air components or fire components, earth components, water components. They tried to find commonalities in their environment, and he saw that there were these four constant things that he saw in his environment. Now, there was another Greek that also thought differently. His name was Democritus. Now, he believed that all matter has to be made up of indivisible pieces, and he called these atomos, and atomos means indivisible. Now, this survived for a while, but then there was a man by the name of Joseph Proust. He came up what he calls the law of definite proportions. Now, what is the law of definite proportions? Well, the law of definite proportions says that a compound always has the same elements in the same proportion. So that means hydrogen, which is H2, when it combines with oxygen, and we just need one oxygen, we're going to get H2O. So that's what the law of definite proportions means. Now, how do we use it? Well, typically, chemists can use amounts of elements to determine the percent by mass. So we look at the percentage of the compound. Like, we'll look at how many atoms of sodium are there in salt, and we can figure out the percent by mass. And you'll do plenty of that practice in class. Percent by mass is always mass of element divided by mass of compound. Now, this formula, I expect you to know it. I'm not going to give it to you, so make sure that you remember this formula. Okay, the next one is law of multiple proportions. So there was an English school teacher who figured out that different compounds are formed by a combination of the same elements. And this is where it gets a little confusing for people. They're going to have different masses. And what you want to do is you want to figure out the mass ratio to figure out the multiple of the atoms that are combined into these substances. And you're probably scratching your head thinking, what are we talking about? Well, an example of this would be water is H2O. Now, the very interesting thing is water can actually be changed and represented by H2O2. H2O2 is hydrogen peroxide, and you've used this numbers of times whenever you've had a boo-boo or you're trying to clean something. So these are multiple proportions, and they're different compounds because the atoms combine in different ratios. Okay, types of elements. This is the organization of the periodic table. There are only 17 nonmetals, so it's a very tiny portion of the right-hand side of the periodic table. Now, in between, it's sort of sandwiched in the middle there, metalloids. They are the steps there that I'll point out to you a number of times. There's only 7 of them, and they have properties of both. And then lastly, the metals. They make up the biggest portion of the periodic table. So please remember, metals contain a large portion of the periodic table. Now this is kind of a review for you. You know that metals are shiny, they conduct electricity, they conduct heat, they're ductile. You can pull them into a wire. Okay, that's what ductile means. Non-metals. Non-metals are much more different. They tend to be dull, so they don't have a nice shiny surface. They do not conduct electricity or heat, and they tend to be brittle. Metalloids, they're a little combination of both of them, and they tend to form big molecules. That's why we call them macromolecules. Some examples of metalloids would be boron, silicon, germanium. Okay, so these are all examples of metalloids. Okay, so to summarize, elements cannot be broken down into simpler substances. Even though we know we have subatomic particles, we're talking about the building blocks of matter. They can be combined into two or more different elements, and that's what we call compounds. The law of definite proportions states that a compound is composed of the same number of elements in same proportion. And then the law of multiple proportions states that if elements form more than one compound, they have whole number ratios.